This is my first attempt at a dual plane balancer. I'm going to go through every part here. I'm going to explain how I did it, how it works, and maybe it can inspire somebody to make something of their own. So basically I'm going to start at the base here. It's an aluminum plate. It's actually a checkered plate. But all I did was drilled and tapped some holes for this guide rail here. I think this is 12 millimeter. And it basically allows me to move the distance of the plane. Okay, so we got plane 1 and plane 2 here, or the opposite actually. I made plane 1 is fixed, the motor and everything. Plane 2 is the one that I move. Next we have the actual moving parts of the machine. So we'll start with these little cradles here. Well, I guess I'll call them cradles. So these have holes. These are 3D printed. There are holes in them, so I can place these bearings at different locations and to accommodate different size shafts that could be potential candidates here. So same on this one. These are matched, they're identical. I have these arms here that have little bearings. I think these are 608 bearings, and so that allows that nice little free motion there. It's a little dampened due to the wires. So these move back and forth. When they move, their movement is captured by these accelerometers here. These are ADXL 345. So I have one here and one here. So to be able to connect two of these to the same ESP32, and you can see the data pins for the accelerometers are actually, I put them together, put them into the same pins on the Arduino, or the ESP32, and I'm able to tell the difference between each one because according to the data sheet here, the SDO pin on the accelerometer, which is this one here, can be either grounded, 0, or set high, 1. And what that does is it allows the ESP32 to know which accelerometer it's getting the data from when they dump the data. I mean, that's my basic understanding of it. That's kind of the basics for the vibration part. Now, when you get a vibration signal on a shaft, you want to kind of get a timing reference, right? So my timing reference for now is just this tape. This is all just experimental. It was for a school project, so I had to get it done quickly. But so this tape here is detected by this retroreactive sensor. Okay. I had a bit of, well, not a bit of trouble. I just had to do one little extra step because this is a 12 volt component. I'm lucky I had this actually lying around. It was donated. But basically, since this runs on 12 volts, or it can actually, I think it's 10 to 30. I'm running it on 12, I believe, right now. I had to wire it up, power it using this power supply, but then tap off, like get the signal to this optocoupler here. I have this photo sensor here that detects the tape, the reflective tape, and sets this high or low. So as I pass this tape in front of it, you're going to see that light flash, right? So there you go, right? As you can see, that's what I'm doing. So the way this works is the signal, the input into this circuit here, this is an isolator circuit, And what this circuit does is it allows me to have a high voltage or higher voltage input go to a lower voltage output, and this allows me to basically use this for logic on my ESP32. This just sets a variable high or low when this is high or low, and that gives me my phase. So the way this works is this is 5 volts from the Arduino, this is ground from the Arduino, and this is my digital input pin on the Arduino. And then I have actually grounded the Arduino to the power supply here, but just to share the grounds. And the input from the photoelectric sensor is here, black and white. So white is my ground, black is my hot. So the next part is the motor and belt system. So basically I have just this 12 volt DC motor, which is controlled by this speed controller, and I can really ramp it up here, but I'm usually on the lower RPMs for now. I have this belt system here that's can accommodate many different sizes of rotors. So as you can see here, I'm going to install a rotor. I take my belt. This is surgical tubing here. I cut it to length and then glued the ends together using a super glue. That's the joint right there. I put the rotor on my carriages here, or my cradles. I run it down like this, up on here, and then up on this. And I should probably turn off my motor here. All right. So now I'm gonna show you guys everything spinning. First, I have to calibrate my photoelectric sensor here. So I have to put it on. It's actually better if I go on the other side. So I'm gonna use this as my reference. Low on the tape and high on the duct tape. Okay. So let's start it up. This shaft is gonna start rotating. This is obviously an extreme example, but it could happen where you make something that's this imbalanced and you have to balance it. So that's just a really off-center hole. And as you can see, that's a statically, obviously unbalanced, right? But this is just for demo right now, so I passed my class. And let's see here. All right. Let's turn it on. So I'm going to turn this potentiometer. Oh shit, yes, it's hitting. Just got to get it just right. I think that looks pretty good. You can check the output here. So as you can see, this is the waveform. I'm going to try to get a nice sample here. Maybe I can increase the RPM a tad. Oh yeah, there we go. So let's run it. Oh yeah. Come on now. There we go. So as you can see, this is the data acquired. So this is just from the serial plotter. Eventually I'm going to make something more sophisticated that calculates the phase of the imbalance. As you can see, this is the peak acceleration, positive and negative. And this is the pulse from the tape every time it passes by. So I know that the pulse of the tape, right, is approximately at the positive x acceleration max, right, for both sensors. And you can see that also both planes are pretty much in phase, right, and that one plane has worse imbalance than the other. And that makes sense because this is the blue plane and this is the orange plane. and the imbalance is actually closer to the blue plane. So it's nice to see results actually match up with reality. So here we are. That's the first phase of this project. I'm going to be making another one, probably bigger, to do tires. This is more of a just get my feet wet, and yeah, this shaft doesn't have to be long, you know, probably cut it, but why cut a shaft? It's perfectly good, you know. Might want to use it for something else. So yeah, I think I covered it all. Hopefully this video was inspiring to some, and please like and subscribe, and I guess that's all I have to say, really.